Okay, so this is what our table should look like with all our data filled in. Obviously, you're not going to have this little equation which I've thrown down here, but it's the one we looked at in last lesson. So what we want to do now is create a table over here, which we can turn into a graph, and our graph will have a rise that is equal to 2s and a run which is sine theta t squared. So a y-axis of 2s and an x-axis of sine theta 2 squared. So that t squared. So what that'll tell us is it'll have a gradient that'll be equal to the rise over the run, which will be our g. So we can calculate the gradient from that graph. Now this is a fantastic way in science to turn data into values that are useful for us using equations. And I'm going to show you two methods to get that value for a slope. One is more translatable further down the track, and one's more of sort of a cheat, I guess you'd say. So, firstly, I'm going to put my x values in here. Now, I'm just going to call this the sine one, which is obviously going to be equal to sine theta t squared, but I'm not going to write it all out because it's tedious using the equation tool. And this one is going to be equal to 2s. I want to start with the 2s one because that's nice and simple. So that is going to equal 2, and we use our asterisk symbol for times, and the s value is over here in B5. I'm going to hit enter, and that equation is now in. Now here's that little square, drag it down to complete those formulas into those other boxes. Nice and easy. Now this one is a bit challenging. So we're trying to write sine theta t squared. So we're going to go equals. We can use the sine function. Unfortunately, the sine function works in radians, so we're going to have to use the radians function to convert our degrees. Now our angle is over here at 2, C5 in my case. Bracket. I'm now going to times that by our t squared, which is going to be g5, that average. Oops, sorry, I need to have a bracket in there. What am I doing? G5, get that bracket going in there, and I'm going to times that by another g5. Oh, yes please. I always forget to put that bracket on the end. So, to have another look, that is sine radians C5 times G5 times G5. And once again, I'm going to drag that down, and that's going to populate those boxes there. Okay, so first I'm going to show you the better way to do this, which is I'm going to select my x and my y values, insert a scatter graph. Plotted that data there now, and I'm going to click on one of those points and add a trend line. In other words, that's a line of best fit. Now it does give you a bunch of options for lines of best fit, and the one we're looking for is our linear, which it defaults to. So once it gives us that, we can now click display equation on chart. Now using our equation for a line, y equals mx plus b, the m being the gradient, we've got a gradient there of 9.8 meters per second, that is my acceleration. Now obviously my value has turned out pretty well. Now I want to show you the other way to do this, which is more of a, like I said, sort of like a cheat code, rather than doing this long tedious method. But like I said, you still could be required to do this further years down the line in science, where you need to actually draw up a graph and extrapolate that line of best fit. But here's the other easy way to do this. We can just go equals, and we use the slope function. And if we click on that slope, it tells us exactly what we need to do here. So I want the known y's, which are these, comma, known x's, bracket, enter, boom, and just calculated the same value that I got off that equation there, 9.79. Now, it's very unlikely you guys will get close to 9.8, which is the known value for the acceleration of gravity. The only reason mine was so good was because I calculated those values rather than did the experiment myself. Mine does not take into account things like error and friction and other forces that could be affecting this. But in your case, yours is going to be more truer values for an experiment, so to speak. But it'll probably be less than that value, I would imagine. In the quiz to follow, you need to put in your value and explain why potentially your value is off from the known value of 9.8 meters per second.